All right, time for a basic video on describing motion, going through some of the key topics that we talked about in this particular unit. You need to know all these descriptions in order to be able to do Newton's laws well, so it's definitely worth going through again. One of our basic descriptions of motion is speed. Speed is rate of change in position. It tells us how fast the object changes position. When you say something's moving fast, what you mean is that they are going from point A to point B in a short amount of time. If you say something's going slow, you're saying it goes from point A to point B in a longer period of time. Rate of change in position. Most rates tell us the amount of time it takes for something to occur. There are three types of speed: average, instantaneous, and constant, and they're all quite different. Average speed is the speed over a period of time. Over 30 seconds, 30 hours, 30 days, over some period of time. Example would be to say that my average speed on a trip to Charlotte is 45 miles per hour. That is my average speed over the entire trip, say 45 minutes worth of time. It's very general information, doesn't tell us a whole lot. Just gives us a general idea of how fast I was going. Kind of like an average grade. If your average grade is 85%, that doesn't tell us anything specific. It just says if I took all your grades, averaged them up, I'd get 85%. You may never have made an 85% on anything I gave you. You may have failed some things. You may have gotten 100% on some things. I have no way of knowing. Average speed is just as general. If I say I'm going 45 miles per hour average on a trip to Charlotte, doesn't mean I ever went 45 miles an hour. I may have gone faster. I may have gone slower. I have no way of knowing. Average speeds are good for calculating distances and times it might take to get somewhere. Like if I wanted to plan a trip, I would use an average speed. If I was planning a trip to Yellowstone National Park, I would say my average speed will be about 60 miles per hour. Using that in the speed equation, I can calculate how many days it's going to take to get there. I can calculate how far I can go between stops. If I'm planning a trip, average speed is what I use. Instantaneous speed is speed right this instant. I always tell students, what does it mean when your parents say, get over here right this instant? The answer is, it means get over here right now. Instantaneous speed is your speed right now. Things like speedometers or radar guns measure instantaneous speed. This is our day-to-day kind of speed. This is the kind of speed that we use when we're driving to Walmart. We want to know how fast we're going right now, so we can look at the speedometer to figure out how fast we're going right now. Very specific information. If I say my instantaneous speed is 50 miles per hour, that doesn't mean I was going 50 miles per hour before it. Doesn't mean I'll be going 50 miles per hour after it. Only at that one moment in time I was going 50 miles per hour. Kind of like a test grade. If you get an 85% on a test, that's how well you were doing right that moment. Doesn't mean you got 85 on the test before, doesn't mean you'll get 85 on the next test. It's very specific to that one instant. Constant speed is speed that doesn't change. Anything that's constant doesn't change. Constant speed of 40 miles per hour means I'm going 45 miles or 40 miles per hour the whole time. If I am going 40 miles per hour the whole time, my average and instantaneous speed will be the same. If I have a constant speed of 40 miles per hour, that means if I averaged all my speeds out, it would be 40 miles per hour. If I look at my speed at each instant, it'll be 40 miles per hour. When speed is constant, average and instantaneous are the same. Constant speed is hard to find on Earth because there's too many things that get in the way. Hills, turn, friction, air resistance, all these things will speed us up, slow us down, and it kind of prevents a lot of constant speed. In space, it's normal. Most things in space move at a constant speed. The Earth orbits the Sun at a constant speed. Doesn't speed up, doesn't slow down. Speed can be calculated. The equation is pretty simple. Speed equals distance over time. This is a division problem. Whenever you see it set up like a fraction, you're dividing. Top number divided by bottom number. A lot of students put it in the calculator backwards. Make sure you don't. Read it like you do the page of a book, top to bottom. Put this number in, divided by this number. This is a straightforward example of it. If a car travels 30 miles in 2.3 hours, what's its average speed? We've got to figure out what our distance and time are. The units do that for us. Miles measure distance, so we know that goes on top. Hours measure time, so we know that goes on the bottom. 30 divided by 2.3 is 13. Now we need a unit. We write down exactly what we see here. Miles over hours, miles per hour. Now that's straightforward. You may be working with things straightforward. Be careful. If I would have asked for the average speed in miles per second, you would have had to change your hours into seconds first. But a lot of times you'll just see it like this, where you're calculating speed. You may have to do this algebraically, and because I'm limited to 15 minutes on YouTube, I'm not going to go through an algebra example, but I will show you this. If you draw a triangle and put a y inside of it, and take the speed equation and stick it in that triangle exactly the way you see it, you can use this as a shortcut to your algebra. What this means is if I'm calculating speed, I'll cover speed up. I'll take distance over time, or distance divided by time. If I'm calculating time, I'll cover it up, and I'll take distance divided by speed, or distance over speed. It's a little shortcut to help you with the algebra if you're having trouble with it. If you want to find distance, you'll take speed times time. If they're above and below, it's division, top number divided by bottom number. If they're on the same level as each other, you multiply speed times time. It's one of the shortcuts that you can use to calculate distances and times. Again, I don't have really time to go into it. Velocity, not the same as speed. Velocity is speed and direction. It adds that second thing to it. It's similar to speed in that it includes average, constant, and instantaneous. Average velocity is velocity over a period of time. Constant velocity is velocity that doesn't change. Instantaneous velocity is velocity at one moment in time, right this instant, right now. There's a slight difference in the constant thing here. Constant speed means your speed doesn't change. Constant velocity means your speed and direction don't change. Constant speed is hard to find on Earth. Constant velocity is nearly impossible. Because to have a constant velocity, you have to be moving at the same speed in a straight line. And most of the time on Earth, things don't move in straight lines. So constant velocity is even harder to find than constant speed is. But it means the same thing. It doesn't change. One of the big differences between speed and velocity is in the way it's calculated. Speed is distance over time. Velocity is displacement over time. Velocity is based on displacement rather than distance. And to understand that, we need to take a look at what distance and displacement are, what the difference is between those two things. First, distance is your total amount of travel. It's how far you went. It's how far the car went. You are the frame of reference. If I say I drove 15 miles to get to Walmart, I'm probably talking about a distance. I drove 5 miles down one street, 5 miles down the next street, 5 miles down a third street. Add those all together, I went 15 miles. This is what the odometer gives us on a car. It tells us the total distance that the car has traveled. Displacement changes the frame of reference. Instead of the car being the frame of reference, instead of us being the frame of reference, our starting position is the frame of reference. So if I say Walmart is 7 miles from my house, that is the displacement. Here we're talking about going down one street, going down another, going down a third street. Here we're talking about the straight line between the two. If I got on a map and looked at the straight line between the two, I'm looking at my displacement. And again, velocity is based on displacement, not distance. Most of the time, these things are two very different numbers. If I roll a ball across this table, my distance and displacement will be the same. It's a short distance. I can go in a straight line from one place to another. But if I want to leave my room and walk to the office, my distance and displacement end up being two completely different things. The distance is how far it is out my room, down one hall, down another hall, add them all up. That's my distance. My displacement is the straight line from here to the front office. These are going to be two different numbers in that situation. So my speed and velocity will be two different numbers in that situation. Now, good news for you is that when the state does its calculations, it assumes your objects are moving in straight lines. So the distance and displacement will end up being the same in physical science. One last description, acceleration, rate of change in velocity, how fast the velocity changes. If something has a high rate of acceleration, that means it changes velocity quickly. If something has a low rate of acceleration, that means it changes velocity slowly. Now, because it's based on velocity, acceleration can be speeding up, slowing down, or turning. Remember, velocity is speed and direction. We can speed something up and say it's accelerating. We can slow something down and say it's accelerating, because in both cases we're changing speed. But turning is also a change in velocity. We're changing direction, so it too has to be considered acceleration. An object turning at a constant speed is accelerating because its direction changes. Acceleration is also a calculated value, change in velocity over change in time. Now, when I did it in class, I didn't write change as velocity in the equation. I wrote VF minus VI, final velocity minus initial or starting velocity. This is change in velocity. We take change in velocity divided by time. Here's a straightforward example of it. A car goes from 20 miles per hour. From means that's where we started. To 60 miles per hour. To means that's where we ended. Again, it's ending minus starting, final minus initial. And we did it in 30 seconds. Seconds measure time. Now, we got to do this change in velocity first. We got to take 60 minus 20 before we do anything else. We simplify that to 40 miles per hour. Now we can divide it out. 40 divided by 30 is 1.3. Again, I'm rounding. Unit for this, just what we see, miles per hour over seconds or miles per hour per second. This is a straightforward equation. You will never have to do this one algebraically, so no need to worry about that. Now, because there is subtraction involved, our acceleration can be positive or negative. If VF is bigger, it'll be positive. If VF is smaller, it'll be negative. Positive acceleration happens anytime the object is speeding up. Negative acceleration happens anytime the object is slowing down. Our acceleration in that example was positive because our car sped up from 20 to 60. As is always the case, if you have any questions on this, make sure you ask me in class. Make sure you put them on the wall. Again, it's important that we know this so we can work with Newton's laws more effectively.